Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome to this video where we will discuss the end of term coverage for grade 11 advanced mathematics, term 3 of course. And I would like you to know that it will not be only one part, it will be 5 parts, and each part will cover a unit, and each part will also have 2 parts in it, 2 components. And the first part will discuss the topic itself, will remind of some concepts and equations, and in the second part we'll discuss the questions, we will solve them and see if there is any tricky questions, and we'll see how we can evaluate them and solve them. So if you feel that you are confident enough with the topics, please skip to the second part of the video. Now, in this video, we will discuss vectors, and if again you're confident with vectors, you can skip to the second part of the video. So what are vectors? Vectors look like this. They have 2 parts. They have this part, which is called a head or a tip, and this part, which is called a tail. And vectors are really useful when representing some physical quantities in terms of 2 things, magnitude and direction. So they represent magnitude first, and the magnitude is actually represented by the length of the vector itself. The second thing they represent is direction, and the direction is the direction where the head or the tip points into. The first concept that I want to explain is vector addition. Vector addition, because it's really different than normal addition. And in normal addition, if you have 2 quantities, for example 5 plus 3, you just add them directly and you will get a certain result. However, when talking about vectors, if we have, for example, this vector, let's call it A, and we have this vector called B, for example, the result of the addition of the vector A and the vector B is not equal to A plus B. It's not equal to their magnitude addition at all, right? Because if we would have to look at how the addition looks like, let me change the color of this. So the result is gonna look something like this. It's gonna look like A. I just redrawed A, and then I will redraw B, but starting from the head of A itself. So I will redraw A here again, I mean B. So this is B, and the result is actually going to be from the tail of A to the head of B. So it's gonna look like this. So this here is really the result of the addition of the 2 vectors A and B. And from this idea, we can extend further. Now, one of the important things that we have to discuss when discussing vectors is the idea of magnitudes, how to find the magnitude of certain vectors. Now, as a start, let's talk about the magnitude of an addition of vectors. For example, let's consider this situation where we have a vector A, let's say equal to 3, and a vector B that is equal to, for example, 5. And they have an angle between them. Let me change the color. Oops. Okay. So they have an angle between them. Theta is equal to, let's say, 75 degrees, for example. How will we get the resultant vector? Let me redraw it again here. So we'll have 3, and then we'll have 5, and then we have an angle here which is 75, and we learned that finding the resultant vector is from going to the tail of the first one to the head of the second one. So it's going to look something like this. Now to find the length of the tallest side or the longest side from two side lengths and an angle theta between them is found, the length of this is found using the cosine theorem, right? Let's call this vector C, for example. So the magnitude of C is represented by C inside some absolute value, or some people call it a modulus, right? So the magnitude of the vector C, in this case, because this triangle is not right, we have an angle of 75, not 90, is going to be found using the cosine theorem. So let's represent it using the variables at first, and then we will substitute them with numbers. So C is going to be equal to the square root of a squared plus b squared minus 2ab cosine the angle between them, theta. This is how you find the magnitude C. So let's do it for this case here. I will solve it here, for example. So to find the magnitude or the modulus of C is going to be equal to the square root of 3 squared plus 5 squared minus 2 times 3 times 5 times cosine 75. And now feel free to use your calculator. I'm just going to simplify it quickly. So the square root of 9 plus 25 minus 6 times 5, that's 30, times cosine 75. And here 9 plus 25 is just 34 minus 30, so the square root of 4 times cosine 75, and it's going to be equal to some value, and you can use the calculator to solve it. So it's going to be 2 times square root of cosine 75. And this is how we find the magnitude for this case. Now, of course, I would like to remind that you have to have your calculator in degree mode, not radian mode, if we will use degrees. So this is important for you to get the correct result. And now let's move to another type of magnitude, finding the magnitude, but in this case, we will have the right angle. So let's assume that we have some vector, let's call it again C, and then we have two vectors that resulted in it. So we have a vector here, for example, 3 and then 4. This is the magnitude, for example, this is B and this is A. So how do you find C? It's very easy, but in this case I would like to let you know that it is going to be a right angle. So in this case we will not use the cosine theorem, rather we will use the Pythagorean theorem. The Pythagorean theorem, let me remind you, C squared is equal to A squared plus B squared, and to find C itself, the magnitude of C, the modulus of C, is going to be equal to the square root of A squared, so 4 squared, plus B squared, 3 squared, and this is easily the square root of 25, which is 5. So this is the magnitude of C. C is equal to 5. Now let's move to representing vectors. Now, the way we will represent vectors is using something called the component form. The component form it is actually something like this, where you have this type of brackets, and in the start you will have the x projection, and in the end you will have the y projection. Let's compare it to the Cartesian system or the coordinate plane to better understand it. So let's say that we have some coordinate plane here with an axis y and axis x. And let's say that we have this point here. And this point, the coordinates of it will be represented by the ordered pair, where you will have the x value and then the y value. In this case here, in the case of vectors, so this is for the coordinate plane, yeah, or the Cartesian system. Now for vectors, we will also use the coordinate plane. Let me draw it here. So we have also a y versus x. Let's draw a simple vector here. And the way we will represent it is by how much it has a projection on the x-axis, right? So this is ax, assuming this vector is actually called a. This is a. So we will calculate it. We will calculate the component form here by finding the x projection, ax, and then the y projection, how much it went on the y. So this is here, and this is here. This is ay. And this is how we will represent the vector itself. So let's say, for example, we have this situation here where we have, again, a graph, and then we have a vector, and let's say that it has a projection on the x-axis that is going to be, for example, 3 again, and then a projection on the y-axis, or a component in the y-axis, 4. So the way we will describe this vector, let's call it, for example, vector A. So the vector A is equal to 3 in the x, of course, and 4. And the nice thing about this is, let's do something. Let's move this projection here. Let's move it here. So I will keep it, and I will draw the moved vector in another color here. So we moved this here, 4. The nice thing is, what do we have? We have a right angle. So it is easy to find the magnitude of A itself. So the magnitude of A is going to be equal to the square root of 3 squared plus 4 squared, which is again equal to 5. So we can derive an equation kind of for finding the magnitude of any vector. So to find the magnitude of any vector, let's call it A. It's going to be the addition of its components, ax and ay, and it's basically equal to the square root of ax squared, the value of ax squared, plus not b but ay squared. And this is it. Let's have another situation here where we have, again, y versus x, and we have 2 points. We have a first point here. Let's call it, for example, 2 and 1, and a point here which is 5 and, let's say, 4. And what we want to do is connect them by a vector. Connect them by a vector. What will we do? To write a component form for this vector, for example, let's call it A. To write the component form for this vector, what we will have to do is consider the part with the head. We will consider them as x2, y2, and then the part with the tail, we'll consider it as x1, y1. So it's going to be x2 minus x1, and then y2 minus y1. So let's find it for this vector. A is going to be equal to, let me change the color. So A is going to be equal to, what is x2? It's 5. What is x1? It's 2. And then what is y2? It's 4. And what is y1? It's 1. So it is equal to 3 and 3. So this is the component form of the vector A. Can we find its magnitude? Yes, we can find its magnitude. The modulus of A is going to be the square root of 3 squared plus 3 squared, and it's going to be equal to the square root of 18. So this is the magnitude of the vector A in this case. Now let's move into representing components using angles. So we learned before in previous terms, if we look at this thing here called the unit circle, it's not a very good drawing, but let's consider it here where we have y and we have x, of course, here, and we have some line that goes from the origin to the circle itself. This line is 1 unit long and it has some angle theta with the x-axis. What will the x and y projections be? So we know x is going to be 1 times cosine theta, and y is going to be 1 times sine theta. So we can, of course, neglect the 1. Same thing is with the vectors. So let's do it with vectors. So we have this coordinate system and we have some vector A, and it's equal to 8 units, for example, and it makes an angle of 30 degrees with the x-axis. Can we find AX and AY? Yes, we can. So let's draw them. What is AX and AY? So this is AX, and this is AY, which I can draw also here because it's the same thing. This is AY. And the way to find it is, since we have this angle 30 degrees, we can use cosine and sine. So AX is going to be A times cosine 30, cosine the angle theta. So 8 times cosine 30. And we know that cosine 30 is equal to square root of 3 over 2. So it's going to be 4 square root of 3. This is our answer for AX. And for AY, we know it's going to be A times sine theta. Therefore, it's going to be 8 times cosine 30 times, not cosine, but sine 30 in this case. And it's going to be equal to 4. So these are our two answers. Now, at some point, scientists needed to kind of relate between the magnitudes of two vectors and their angle in such a way to make it easier for calculations. Therefore, they developed this kind of idea of the dot product. And it's a really easy equation that has quite a long proof, and we'll discuss it maybe in future videos. So its equation is represented by this. If we have, for example, two vectors, a vector A and a vector B, and they have some angle between them, theta, then their dot product, A dot B, is equal to their magnitudes, their moduluses, multiplied by each other, times cosine of the angle theta between them. And this is really an easy kind of equation. And to find the angle between them, using this equation, we can just manipulate the equation into finding that cosine theta is equal to A dot B divided by the product of their moduluses or magnitudes. And to find theta itself, we just take the cosine inverse. So theta is equal to cosine inverse of this whole expression. So keep this equation in mind. Now we discussed the equation of the dot product itself, but there is another way to actually find it. And to find the dot product of two vectors, let me draw them here. Let's say that we have a vector A and a vector B. What we will have to do is just to multiply their projections. So each vector has an x and y projection if it was in 2 dimensions. So let's say we have ax times bx, and then we add it with the y projections, right? So it's the sum of the product of projections. So ax bx plus ay by. And in case we had a third dimension, a z dimension, we will add az bz as well. And if there is a fourth dimension, we'll add a fourth dimension as well, but we don't have it in reality. A fourth dimension is time. So we can summarize the equations. We have A dot B is equal to ax bx plus ay by plus az bz if we have a third dimension, and it's also equal to the magnitude of the two vectors multiplied by each other times cosine the angle between them. Let's talk now about unit vectors, and it's a really easy concept. We have a unit vector for each dimension. So we have one for the x dimension and a y dimension and the z dimension. The x dimension, we are usually represented with the letter I, and some or most textbooks, what they do is they put some sort of hat notation on it, and then for the y we have a j with a hat as well, and the z is a k. And they're useful because they indicate direction. Let's say, for example, we have this sort of vector. Let's say that vector A is equal to maybe 3i and 4j, for example. And how do we find its magnitude? We can represent this and then find its magnitude. So let's do it. Let me draw a small graph here, x and y. So we know because I represents x, we will go 3 in the x direction. So we will go 3 in the x direction. So we have a vector here that has a magnitude of 3 in the x direction. And then we have another vector with a magnitude of 4 in the y direction. So let's draw it here. So this is going to be 4. So what will the resultant vector be? So to add them, we will move this to this side here. So let me move it. We will have something like this. 4. And the resultant vector is going to be this part here. And what do we notice? We notice that again, we have a right angle, therefore we can use the Pythagorean theorem to find it. So let's find it. Let's find the magnitude of A. So it's going to be equal to the square root of 3 squared plus 4 squared, which is again, as always, 5. Right? So unit vectors are essentially vectors that have only a magnitude of 1 in a specific direction. So let's have a look at this. Let's have a look at I. So we can represent it in component form by this way. It looks like this. It only has 1 unit in the x direction. And then for the j, it only has 1 unit in the y direction. And for the k, we can represent it by a 1 unit in the z direction. And again, this notation really helps us in finding the direction of each vector. So the reason behind the discussion of unit vectors is because I really want to move into the cross products, because they're different than the dot products. So cross products, they look something like this: A cross B. And the way to find A cross B is by using a matrix, all right? By using a matrix. And it depends on basically how many dimensions that we have, but let's say we have 3 dimensions. So using the matrix, let me change the color maybe. So A cross B is going to look something like this. If we have 3 dimensions, then it's going to be I, J, and then K. And then here we will have AX, AY, AZ, and then here BX, BY, and then BZ. And we have another case for cross products. We have when we have, for example, 3 vectors that are being multiplied together to find some volume, for example. So its notation is like this. We will have the third vector, T, multiplied by the cross product of A and B. And the way it looks like is really simple. It's not really hard. So it's going to be T, X, TY, TZ, AX, AY, AZ, and then BX, BY, BZ. And the solution is just the determinant of this, finding its determinant. Let's start solving questions. Now here find the component form of vector AB with initial point of -4, 2 and terminal point of B 3 and -5. Now we learned that the component form will look something like this. So we'll have x2 minus x1, and we will have y2 minus y1. So let's consider the terminal point. The terminal point basically means the head or the tip, and the initial point means the tail. We know that the head is always y2 and x2, so we will consider this to be x2 and y2. So let's write them here. x1 and y1 are -4 and 2, and y2 and apologies, x2, y2 are 3 and -5. So let's do it. So what is x2? We know x2 is 3 minus x1, which is -4. And then we know that we will have y2. What is y2? -5 minus y1, which is 2. 3 minus -4 is 7, and -5 minus 2 is -7. And this is the component form. Now another example here with the same idea. Find the component form of AB with initial point -2 and -7 and terminal point 6 and 1. So again, the component form is going to be like this: x2 minus x1 and then y2 minus y1, and we will consider x1 and y1 to be the initial point, -2 and -7, and the terminal point to be 6 and 1, so x2 and y2. So x2 is going to be 6 minus x1, which is -2, and then we will have y2, which is 1, minus y1, which is -7. Therefore, the result is going to be 8 and 8 as well. So let's also find the component form of this. We have the initial point and we have the terminal point, and the terminal point has x2 and y2, and here we have x1 and y1. Therefore, let's do it. What is x2? That's -9 minus x1, which is 0, and then y2, which is -3 minus y1, which is 8. -9 minus 0 is -9, -3 minus 8 is -11, and this is our result. So here it gets a little bit more interesting. We have a vector with some magnitude and an angle. And from this information, we will have to get the component form itself. And we learned that if we have some vector, in this case v, so we have v, and then vx is actually equal to v itself times cosine the angle theta between it and the axis x. And for vy is going to be v sine the angle theta itself. So if we will visualize it, in this case, let's have an axis y versus x again. We have a vector v, and it is pointing kind of in this direction, and it has a magnitude of 10. So v is equal to 10. And the angle between it and the positive x-axis is 120. So the Vx is going to be equal to, Vx is V cosine theta, and this Vy is going to be V sine theta. And let's find the component form. We learned that the component form is actually can be equal to V cosine theta and V sine theta, right? Because this is just Vx and this is Vy. So from this information, we can just plug in the numbers. We will have V is equal to 10 cosine 120, and here we will have 10 sine 120. In the first case, of course, you can use the calculators, but cosine 120 is just -1/2, so we'll have -5 here, and sine 120 is square root of 3/2, so it's going to be 5√3, and this is our answer. Now let's solve this question. It has a similar idea, so we know that the component form is something like this. It's V times cosine theta and then V sine theta. And let's plug in the numbers. We will have, in the first case, 8 times cosine 45, and then here we will have 8 times sine 45. And we know that cosine and sine 45 is equal to √2/2, so the answer is going to be equal to 4√2 and 4√2, and this is our answer. This question has a similar idea as well. So we know that the component form is equal to V cosine theta and V sine theta, and let's just plug in the numbers. So v is equal to 24, and then we have cosine 210, and the other case we will have 24 sine 210. 24 cosine 210 is just same as 24 cosine negative 13, and it is equal to, if I'm not mistaken, 12 times root 3, and here we will have negative 12. Sorry, this is also negative. And this is our answer. Let's move to this question, which I personally find more interesting. So let's find an angle theta between two vectors. One is u and the other is v, and calculate it to the nearest tenth of a degree. So let me remind you of the dot product. The dot product is u dot v, and it's equal to the magnitude of u times the magnitude of v times cosine the angle theta. And the definition of a dot product is as following. U dot v is equal to, actually let me make v look like this so it's more different than u, so it's more distinguishable. So u dot v is equal to ux v x plus u y v y, and then we can substitute this into this part here. So let's do it. So let's find ux vx plus uy vy. What is ux? It's 6 times vx, that's negative 4, plus uy, that's 2 times 3, and it's equal to negative 24 plus 6, or negative 18. So this is the dot product of u and v. Now let's substitute this negative 18 is actually equal to what? It's equal to the magnitude of u times the magnitude of v times cosine theta. Let's find both of these magnitudes. I will do it in this part here. So to find the magnitude of u, we will have to find the hypotenuse using the Pythagorean theorem. We know we have 6, we have 2, so we can just do this. 6 squared plus 2 squared, right? And what will we get? 6 squared is just 36 plus 4, so the answer is square root of 40. Now let's find it for v. And for v, to find the magnitude, is going to be the square root of negative 4 squared plus 3 squared, which is equal to 16 under the square root plus 9, which is 5. Yeah, because 16 plus 9 is 25, the square root of 25 is 5. So we have both of the magnitudes right now. Let me highlight them here. Now let's substitute them into these parts here. So we will rewrite it as negative 18 is equal to, what is u? U is root of 40 multiplied by 5 multiplied by cosine theta. Now cosine theta, we don't know its value. And to calculate it, we will just use the cosine inverse, right? So using the cosine inverse, we can say that cosine inverse of negative 18 over root 40 times 5 is equal to theta. And of course, this step you can do it straight away using the calculator. However, I just simplified it here. And we will get theta is equal to some value, which I'm going to calculate right now. So cosine inverse of 18 over root 40 times 5, and the answer is 55.3. So the answer here is 55.3 degrees. And this is the answer to the question. Let's kind of revise. So we identified that in order to find the angle, we will have to use the dot product, and step by step we worked out to find this value. And the way that we did it is basically by doing its definition, right? Writing its definition, because the definition of the dot product is multiplying the corresponding projections of the two vectors by each other and finding their sum. So ux vx plus uy vy. And using this, we had the dot product ready. So we got it. And then the second step was finding the magnitudes, and we did them here. So the magnitudes were found in this way by finding them by using, of course, the Pythagorean theorem, and we found them here. And then we are left with one unknown, which was theta. So here we just wrote the whole expression and then kind of rearrange it to find theta itself. Of course, if you write this in your calculator, you will also get the same answer. So a small correction here, theta is actually not equal to 55.3, but rather it's equal to 124.7. So 124.7 degrees. I did a minor mistake in the calculator. And I also checked that if I use this expression, will I get the same answer? And the answer is yes. If you plug this into the calculator, you will also get the same answer. In case you have some doubts in the first question, we will solve the second question to find the angle between two vectors having, of course, their component form. So the first step, I will write some steps here. The first step is to find the dot product. So we have two vectors, u dot v, and finding their products, we will have to multiply the corresponding projections of each one. So ux vx plus uy vy. And let's use the numerical values. So we will have ux is just 3 times vx, which is also 3, plus uy, which is 1 times negative 3. It's equal to 9 minus 3, which is equal to 6. So this is the dot product. The second step is to find the magnitudes of u and v. And why do we do it? Because we want to relate them to this formula that u dot v is equal to the magnitude of u times the magnitude of v cosine theta. Therefore, we want to find u and we want to find v. U can be found, of course, using its values, which is 3 squared plus 1 squared, which is equal to root 10, and v is 3 squared plus minus 3 squared, which is equal to root 18. And then the third step would be combining them into the one formula. So what is u dot v? It's 6, and then it's equal to the magnitude of u, which is root 10, times the magnitude of v, which is root 18, and then times cosine theta. We can either put this in the calculator or rearrange it, and I personally prefer rearranging it. It makes the calculator faster. So how to rearrange it? First of all, I will divide both root 10 and root 18 from both sides. Root 10 times root 18. And of course, these will cancel out. Therefore, we will get 6 over root 10 times root 18 is equal to cosine theta. And then what we do is just cancel the cosine by multiplying by cosine inverse to both sides. So we'll multiply here by the inverse cosine, and we'll multiply here as well by inverse cosine, for example here. Therefore, our result is going to be cosine inverse of 6 over root 10 times root 18 is equal to theta. Therefore, we can calculate theta now. So using the calculator, of course, let me try here. I hope I don't get a mistake this time because of being rushed. So we will plug this and we will get an answer 63. So theta is equal to 63.4 degrees. And I can verify that it is a correct solution. Now let's repeat the steps for this question as well. So let's find u dot v, and it's equal to again ux vx plus uy vy. Therefore, we can put and substitute the numerical values. So negative 5 times 4 plus negative 2 times 4, and this will give us negative 20 plus or minus 8, so negative 28. And then this was the first step. Let's go to the second step. For the second step, we will calculate the magnitudes for both u and v. So the magnitude of u and the magnitude of v. The magnitude of u is equal to negative 5 squared plus negative 2 squared. And then the magnitude of v is equal to the root of 4 squared plus 4 squared. And then here what we will get 20 on the root of 25 plus 4, which is root 29. And here we will get the root of 16 plus 16, which is 32. And these are the two answers. The third step is just to substitute them into the equation. So the equation, let me remind you with it, it's going to be u dot v is equal to the modulus of u times modulus of v times cosine theta. And let's just substitute the numbers. We can say that u dot v is equal to negative 28, and this is equal to the magnitude of u, which is root 24, times the root of 32, which is the magnitude of v, times cosine theta. And of course, as always, we can rearrange it in a way to make it faster for the calculator. So it's going to be cosine inverse of negative 28 over root 24 times root 32. And let's just calculate this. And we will get 156.8 degrees. And this is our answer. Now for this question, we did a lot of similar things, and let's do this as well. But let's just state what orthogonal means. Orthogonal happens when we have two perpendicular vectors, right? So we have, for example, a vector here and another vector. Let's call this A and a vector B, and they have a right angle between them. And when we find its dot product, for example, A dot B, it's going to be, of course, magnitude of A times magnitude of B times cosine theta. And the thing is, theta is going to be 90 degrees. And what do we know about cosine 90? This whole thing is equal to 0. Therefore, this whole thing is also equal to 0. Therefore, the cross product, the dot product of two orthogonal, which means basically perpendicular vectors, is equal to 0. So if we found the dot product of these two vectors to be 0, then we will know that they are orthogonal. So let's proceed into doing it. So because we have 3 dimensions, u dot v is going to be ux vx plus uy vy plus uz vz. And let's just substitute the numbers. So u dot v is equal to ux times vx 3 times 4 plus uy negative 3 times 7 plus 3 times 3. And what is it equal to? It is equal to 12 minus 21 plus 9. And actually what this is equal to, it is equal to 0. Let's try it. So this part here, 12 minus 21 is equal to negative 9, and negative 9 plus 9 is equal to 0. So yes, they are in fact orthogonal. In this case, we do also the same thing to find the dot product. It is equal to 3 times 5 plus negative 5 times 7 plus 4 times 5. So this is just ux vx, and this part here is uy vy, and this is uz vz. So let's find it. 3 times 5 is 15, minus 5 times 7 is just 35, plus 4 times 5 is 20. When you attempt to plug it in the calculator, you will actually get 0 as well. And since it's 0, we can say that these two vectors are indeed orthogonal. Now let's find the area of a parallelogram with adjacent sides with these values. Now to find the area of a parallelogram with certain adjacent sides, we have to get the cross product. This is how we find it. So we have to get u cross v. And the way to get it, it's not like the dot product, it's by finding the determinant of the 3 by 3 matrix that consists of these values. So what I mean basically is this. We have to draw a matrix containing, first of all, I, j, and k, and then the first row will start with all the values regarding u. So we'll have u x, u y, and then u z, and then for the third row we will have vx, vy, and vz. Using this information, we can find the area of this parallelogram. So let's do it. So u cross v is going to be, we always have I, j, and k in the top row, and then we will start with ux. What is ux? Ux is the value, the constant next to the unit vector I. So it's going to be 2. And then uy is going to be 4, and then uz is going to be negative 3. And then for v, we will go with 1, negative 5, and then 3. And then let's remind ourselves, how can we find the determinant of this 3 by 3 matrix? It has 3 steps. The first step is to put a plus, a minus, and then a plus. This is to find the determinant, okay? So determinant of this matrix is going to be equal to this. The first step is put a plus, and then a minus, and then another plus. And then the second step is start by eliminating this row, like this, the first row from the left. And then go to this matrix here and find its determinant. So what is the determinant of 4, negative 3, negative 5, and then a 3? We learned that its determinant is actually equal to this cross, the main diagonal, we call it main diagonal. So the main diagonal minus the second diagonal. And this is important because we will do it 3 times in order to find the determinant of this 3 by 3 matrix. Okay, so let's do it. By using this information, we can find the determinant of this 2 by 2 matrix. I will erase everything to do it again. Okay, so let's find the determinant of 4, -3, -5, and then 3. It's going to be equal to 4 times 3 minus -3 times -5. So it's equal to 12 plus, minus, because we'll have -3 times -5, that's 15, so minus 15, and we'll get -3. So this is the determinant. We will put it here. And then because we erased I, we will put it here. And then for the second part, we'll erase this part. So what we will get? We will get a determinant with these 4 values. So our determinant is going to be 2, -3, 1, and 3. This is our matrix. Sorry, not determinant. Let's find its determinant. So 2 times 3 minus -3 times 1. That's -3 times 1. So it's going to be 6 minus -3, so plus 3, which is equal to 9. So this is our second value here. Minus 9, that's going to be J. Okay? And then our third matrix is going to be this one. So 2, 4, 1, and -5. Let's find this determinant. So it's main diagonal. So 2 times -5. That's a horrible looking 5. And then minus 4 times 1. So we will get -10 minus 4, which is equal to -14. And then we will put this 14 here along with a k. So after all of this, let me erase all of this here. We will get our final kind of vector that really represents the area of a parallelogram. But we're not done yet, but I will rewrite it here. So -3i minus 9j plus 14k. And honestly, to be, the best possible scientifically, I will put like the hat notation here. It is important for us to know that this is not the area because it's still in vector form, kind of. Therefore, to find the area of a parallelogram, we will have to find the magnitude of this vector. We have to find the magnitude of this vector. How do we do it? It's not very hard. It's going to be the square root of the first value here, so -3 squared minus or plus -9 squared plus 14 squared. And this is going to be equal to some value. Let me check it. So it's going to be 3 squared, and then 9 squared, and then 14 squared, and 16.9. So it's 16.9. And of course, let's not forget the unit is going to be unit cubed, or cubic units. And here we go. We have an answer. And like this, we finished all of the material for the first unit in mathematics end of term coverage. I hope you learned from this, and in case you have any questions, please feel free to contact me through my email ahmed.faisal11@outlook.com. It will be there in the comments section, or in the description, down below. Feel free to contact me at any time if you have any questions. Thank you very much.